Hello, it's the final week of the Quantitative Methods course. This week we cover a topic I've called modelling, but really it's all about issues you might get when you deal with real data and how not to fall in those pitfalls when you're doing your assignment, and questions about how to design research so that we can actually measure the things we're intending to measure. So first I'll cover a few of the topics which are in the textbook. One is so-called spurious correlations, which are particularly common in time series. Tends to be if things are trending in one direction, whether it's up or down, you're going to find a positive correlation between the two things, even though they really have nothing at all to do with each other. So I'll show you in the lecture some of the checks we can do on the data to see if there really is a relationship there at all, or whether they just happen to be things that happen to be moving in the same direction. And that can also be the case that other variables like population, which vary widely across countries or regions or households, countries or households with more people have more of other things, and that might make things appear to be related, but when we do a per capita measure they may not be related anymore, so we'll look at that as well. Then there's a whole issue of, well, let's have a look at the residuals from a regression model and try to use those to diagnose if there are any problems with the model. The most common or basic one we'll look at is heteroskedasticity, which is a long word which means the variance is not constant across all observations, but probably actually varies with one of our explanatory variables. That's the variance of the residuals. Not a problem in terms of it doesn't bias estimates of the regression coefficients, but it does affect the estimates of the standard errors, and so it will affect some of the conclusions we'd come to. So there are various ways of dealing with that, and we'll look at a couple of those also in the lecture. Finally, the sort of stuff from a textbook is the issue of nonlinearity in our data. So the regression model assumes our data is linear, or at least the model is linear. What happens when the model, or the real model, is not linear? One way to approach that is to use a logarithmic model, which we've already talked about a couple of times throughout this section of the course, and another way is to use a polynomial model that has like the square of explanatory variables or their cubes or other such functions added to the regression. That's often a problem because we run into multicollinearity, as we talked about in the last lecture, but we'll mention that briefly as well. And finally, we'll cover some topics I would call research design, which not really covered that much in the textbook, and the whole thing there is which variables we should try to control for or not control for when carrying out a regression analysis. It's important to control for relevant omitted variables, but on the other hand there might be variables that we shouldn't be controlling for because they are ways in which our explanatory variable actually affects the dependent variable. For example, if you were looking at carbon emissions and the effect of growth on carbon emissions, you want to see, well, does economic growth increase the growth of carbon emissions? It wouldn't make sense to control for energy use, because energy use is the direct cause of carbon emissions. We'd be thinking that the growth of the economy is causing energy use to rise, which then causes carbon emissions to rise. If we do a regression of carbon emissions growth on both growth in energy use and growth in income, we probably won't find much of an effect of the growth in income. So that wouldn't be a measure of the effect of growth of income on carbon emissions. On the other hand, we might want to look at the effect of energy use on carbon emissions, in which case that would be the sensible variable to include. So we'll be looking at a case study, a paper that was actually submitted for publication in the journal Ecological Economics. I'll give you a handout about that and we'll critique what those authors did. And finally, there are some ways to deal with omitted variables biases or reduce their effect, and we'll talk about those as well. I'm thinking for the final tutorial, I haven't actually written up a tutorial sheet as such as yet. What I'm thinking is that if we can get 2 or 3 students in each group to actually bring in their data on a flash drive or email it to me previously as an Excel spreadsheet, then what I would like to do is actually look at that data on the computer and give some suggestions and discussion about how we might address the question of issue and what issues might be involved in dealing with that particular data. So some sort of hands-on clinic with 2 or 3 examples over the tutorial period. Obviously, I couldn't handle everyone's data in the tutorial, but hopefully if we go over a few examples, that will help other people as well think about how to approach their data. I imagine not everyone will have their data together by the final tutorial either, but it'd be really nice if a few did. Otherwise, I'll bring in some other data sets to play with, which we haven't seen previously, maybe from my previous research. Hopefully that will give people a bit more idea of how to deal with real data. So if you are interested in doing that, either email me the data before the tutorial as an Excel file or bring it in on the day on the flash drive. Okay, well that's it. Hope to see you in lectures and the tutorials.